Hi, I'm Stephen Elliott, President and Life Scientist for Coherence LLC. It's a pleasure to speak with you today, and thank you, Mark, for the invitation. I'll be sharing with you the brief presentation, Coherence, the Big Picture. I find Wikipedia's definition of coherence to be more than adequate. That is, coherence is a property of waves that enable stationary interference. More generally, it relates to the correlation of all of the physical quantities of a wave. Stationary interference refers to the fact that if we have two perfectly coherent waves and they collide, they will perfectly cancel each other or negate each other in every regard. As we're thinking of wave action in the human body and the coherence of those waves, we're thinking of how those waves demonstrate the physical quantities of amplitude, phase, and frequency over time. That is, how consecutive waves demonstrate these quantities persistently. In this regard, we can think of coherence as being a broad measure of rhythmicity, and as we know, waves cannot exist without rhythmicity. Wave phenomena in the body is primarily an outcome of diaphragm movement. The diaphragm, as we know, moves up and down, up when we exhale, down when we inhale, and in so doing it modulates the internal pressures of abdominal and thoracic cavities. And in so doing, it modulates airflow, blood flow, and autonomic emphasis. That is, the autonomic nervous system swinging from sympathetic to parasympathetic to sympathetic with each cycle of respiration. And an outcome of autonomic emphasis is the change in heartbeat. This is generally thought to be due to baroreceptor response and to the ANS response to stretch receptors in the chest. And of course, the abstraction of the heartbeat rate, that is the heart rate variability cycle, which we know has a tendency the heart rate has a tendency to increase as we inhale and decrease as we exhale, in keeping with the phenomenon of respiratory sinus arrhythmia. The body also demonstrates wave-like action in movement, for example, walking, and interestingly, many of the physical structures of the spine are wave-like in nature and demonstrate resonance. So where there is wave phenomena, the potential exists for those waves to demonstrate coherence or not. That is, on a spectrum or a scale, with coherence at one end and incoherence at the other. I like to think of the diaphragm as the Tai Chi diaphragm, in that it is the job of the diaphragm to create and maintain dynamic equilibrium in the body. Again, it does this through its upward and downward movement, where upward movement increases pressure in the thoracic cavity and at the same time decreases pressure in the abdominal cavity. As the diaphragm moves down, it decreases pressure in the thoracic cavity but increases pressure in the abdominal cavity. This has dramatic effect on the entirety of the body, and in particular it creates wave action in the blood flow and the airflow and other activities of the nervous system. It does this through the mechanisms of the thoracic and abdominal pumps. The torso consists of these two primary sealed cavities, pneumatically sealed cavities. The pressure in them is maintained very carefully relative to the external environmental pressure, the atmospheric pressure. The pressures in them are modulated then by the diaphragm, which, when it moves, changes the volume of each of these cavities. As the diaphragm moves up, the volume of the thoracic cavity becomes smaller, and therefore the pressure increases. As the diaphragm moves up, the volume of the abdominal cavity increases, and therefore the pressure in the abdominal cavity decreases. As the diaphragm moves down, the opposite occurs. That is, the volume of the thoracic cavity becomes greater and the volume of the abdominal cavity becomes less. Pressure is following. In this regard, diaphragm movement has a dramatic effect an alternating effect on the pressures in these respective cavities, and flows we'll see through them. Activities above and below the diaphragm are arranged in a very, very elegant way, such that they're alternating in nature. We know that as we inhale, the heart rate has a tendency to increase, and as we exhale, it has a tendency to decrease. This is an outcome of sympathetic and parasympathetic activities, sympathetic nerve endings secreting norepinephrine, which activate adrenergic receptors, which stimulate cardiac activity. Yet vagus nerve endings secrete acetylcholine, activating cholinergic receptors, inhibiting cardiac activity, yet stimulating gastrointestinal activity, such that the actions above and below are opposite in nature. As the diaphragm moves up, the heart rate slows down, but the enteric nervous system action speeds up. As the diaphragm moves down, the heart rate speeds up, but the enteric nervous system action slows down. Why might that make sense? Because the body is arranged such that the diaphragm is to play an important part in the movement of digestive material through the gut. And the diaphragm is to play an important part in the movement of blood through the heart. If we look at the action of blood in the body as a function of the thoracic pump in particular, but also involving the abdominal pump, this is what it looks like with slow, shallow breathing. This instrument is Valsalva Wave Pro, which allows us to look at the effects of blood volume as a function of respiration, as well as the heartbeat. The blood volume wave is this wave defined by the cardiac diastoles along the bottom, and we can see that there is some slight variation of it due to shallow respiration, and we can see that the heartbeats are all roughly the same amplitude, and the interbeat interval between them is essentially equivalent. If, however, we look at the blood volume wave and the heart rate, this is the Valsalva wave of coherent breathing, we find there's dramatic variation and demonstration of multiple coherencies going on simultaneously. We see rising and falling of the blood wave as a function of respiration, a dramatic changes there. We see the amplitude of the pulses rising and falling with the amplitude of the respiratory wave, dramatic changes there. And we see the interbeat interval also changing in a consistent way, becoming longer as the blood wave rises and shorter as the blood wave falls. So we see the respiratory wave, we see pulse amplitude, and we see interbeat interval all changing in a consistent way. It's worth noting that this wave demonstrates a difference in cardiac systole and diastole from peak to valley of about 70 millimeters of mercury. If we plot the red wave of that chart along the cardiac diastoles, we derive this red smooth wave, this being the smooth Valsalva wave. And we see, when plotted along with the heart rate variability cycle simultaneously, that they are roughly 180 degrees out of phase. At near resonance, there is about a 1 second difference or delay between the action of the Valsalva wave and the action of the heart rate variability cycle. So here we see the Valsalva wave beginning to increase, that is, go positive from its valley, and about a second later we see the heart rate variability cycle begin to descend, starting to go negative from its peak. Here at the peak of the Valsalva wave, about a second after its peak, we see the peak or the valley of the heart rate variability cycle beginning to turn up. So roughly 180 degree out of phase arrangement with about a 1 second delay between action of the blood flow as a function of respiration and the follow-on action of the autonomic nervous system and its governance of the heart rate variability cycle. Another view of the Valsalva wave as a function of respiration and of the changing pressures of the thoracic and abdominal cavities, here viewed at the medial cubital vein. This is a little different, but very rhythmic, very coherent. Here we see the blood in the medial cubital vein filling during exhalation and emptying during inhalation. Why emptying during inhalation? Because the negative pressure in the thoracic cavity is drawing blood back through the right heart, the vena cava, ultimately the medial cubital vein, emptying it during inhalation. The lungs filling with a large volume of blood during the inhalation process, and then that blood being ejected back out into the arterial tree during exhalation. If we look at the power spectra of these two phenomena simultaneously, that is the power spectra of the blood volume wave or the Valsalva wave, we've called this the Valsalva wave because this blood volume wave is arterial and venous in nature. Antonio Valsalva's initials, AV, seemed appropriate. And if we plot that in time along with the heart rate variability, the spectra of the heart rate variability cycle simultaneously, we see they are virtually identical in frequency, as we would expect that they would be. In keeping with our understanding of respiratory sinus arrhythmia and baroreceptor action, we would expect the heart rate variability cycle to follow the Valsalva wave cycle and the spectra to be essentially identical. On the psychology of coherence, borrowing Steven Pinker's notion that the mind is what the brain does, I offer then that a healthy mind is a healthy brain doing what a healthy brain does. And given that the brain is a physical aspect of the body, then a healthy brain is an outcome of a healthy body. Therefore, a healthy mind is ultimately an outcome of a healthy body. In this regard, I like to think of it as physiopsychological coherence instead of psychophysiological coherence, in that I believe that coherence of the psychology or of the mind is ultimately an outcome of coherence of the body. In summary, the body is arranged in such a way that there is a very elegant, coherent interplay of sympathetic and parasympathetic systems. This is very much like a pendulum that swings back and forth. The range of motion is a function of diaphragm depth, of diaphragm movement, and ultimately breathing depth and breathing coherence. What is the range of the swing? And is the motion coherent or incoherent? Ultimately, for the swing to be great, depth must be relatively great and respiration must be relatively coherent. Then it comes down to a question of balance. Most of us want to reside here when we're active, alert, and going about our daily lives. This requires the pendulum to swing widely and coherently. We also want to sleep at night soundly. That also necessitates autonomic nervous system function. There is a time to be anxious, but when an event is over, we would like anxiety to diminish, and we'd like to return to a state of being vital or being at rest. And lastly, the opportunity exists for sympathetic and parasympathetic emphasis to both be weak, where I call this puny. That is, energy production's at a low, circulation's at a low, gas exchanges at a low. We move throughout all of these during the course of a normal day. I offer that we can do so very deliberately through our use of coherent breathing and its result, autonomic nervous system balance and coherence. With that, thank you very much. Good day.